Hello guys, so today we are going to start today Leetcode question, and this is export Honda and you are watching on the YouTube. So let's start today. Today we have 2316 question, that is you can say uh, count unreachable pair of nodes in an undirected graph. Okay, so we will see this question and let's read the question from here now. So you are given an integer n and there is an undirected graph, right? And having n nodes, number from 0 to n minus 1 means this is not connected, right? N minus 1. So you are given an 2D integer, right? As is where s of I is a and b, denotes that exists an undirected edge which is connecting node A and B. Okay, now it is saying that return the number of pairs of different nodes that are unreachable from each other, right? So you understand that we have this question, and this question is, we have given an undirected graph, right? Total n integers we have given as a node. These nodes are level from n0 to n minus 1, and on edges we have given, so edges contains connection between two nodes a and b you can say, and this is undirected edge. Okay, so if we'll talk about the what we have to do, so we have to return the number of pairs of different nodes that are unreachable from each other. Okay, so which are unreachable, right? So that we will see. So if you see this example one, so in the example one you will see we have given n equal to 3, right? And then we have given edge that is from 0 to 1. So we can see we are talking about this path, right? And then it is given 0 to 2, means we are talking about this path, and again we have given 1 to 2, so we are talking about this one, like this we have given, right? And this is undirected. So saying that there is no pair, right? As you can see, each pairs are connected with each other, right? So there is no other than these three nodes that have, you can say, different nodes that are not, you can say, are unreachable node, you can say, right? Each node are connected with each other, right? So there is no other than 0 1 2 nodes that have here, and that's why we can say it's returning 0 pairs, right? We don't have to return anything, right? So that's why in the explanation is saying there are no pairs of nodes that are unreachable from each other, because we don't have, so we are returning 0. Now if we'll talk about this example 2, right? So you can see we have 0 is connected with what? Let's see the edges. 0 is connected with 2, so we are talking about this one. Then we have 0 to 5, yeah, this is connected. Now 2 to 4 we are connected. Now 1 to 6 we are connected, and 5 to 4 we are connected, right? So if you'll see this one, what are the things are missing, right? So let me change the color. Yeah, so if you'll see this node is not connect, right? And this node should be connected, right? Or either any other also is connected, right? So the possibility is that either 5 3 is not 5 3 should be connected, right? So it should be connected with we can say 3 and 1, and 1 should also be connected with somewhere. Either this can be here, or this can be connected with here, right? This can go be connected with here, this can go connect with here, right? Here. So possibilities is many here, right? So if we'll talk about what are those possibilities, right, after this one, so let's see. The first of all, it is saying that there are 14 pairs, right? We have, so 14 pairs are unreachable from each other. What are those pairs? So there should be one connection with 0 to, we can say, 1. Let's suppose I am going to connect here, or you can connect from here also. Next one we have this one. Next one we have 0 to 6. This connection should be between 0 to 6. Now we have 1 and 2, right? From 1 and 2. Then it is 1 and 4. So there can be connection 1 and 4 and 1 and 5, like this we have. Now we'll check with the 2 3, so 2 should be connected with 3. So like that, these are possibilities we have given here, and you can see the explanation, and that's why if you count total pairs, it is showing what, 14. Okay, so I think you have got the idea like what to do and how to find the pairs of unreachable pairs, right? If we'll talk about the constant, right? So constant we have, when n is given the more than 1 and less than, greater than equal to 1, and it should be less than 10 to the power 5. Ages we have given greater than equal to 0. It can be a 0, or number pair can be, length can be 2 into 10 to the power 5. Next we have ages dot length. It is surely equal to 2, because these two nodes is connected with each other, and nodes value can be greater than equal to 0 or less than equal to n, and both are not equal. Now there is no repeated ages given between you can say nodes. So this question has been asked in multiple times in the Amazon, so this question is very important now if you're preparing for the, you can say, Amazon, right, or any other top companies. It's very important. So we are talking about for more than 2 days we are using about depth first search. So this topic is also related with the depth first search. We have breadth first search, union find, and the graph things, right? So what we will do, first of all, we'll try to implement with the DFS, then we'll go to the, you can say, breadth first search and union find. Next approach we have the int one, in which we will see that find the connected component of the graph, and to find the connected component you can use union find, disjoint set, BFS, DFS, right? Now we have for node u, number of nodes that are unreachable from u is number of nodes that are not in the same connected component, and the number of unreachable nodes from node u will be the same, the number of nodes are unreachable from node v if u and v are belong to the same components. So these you can think about this we have given, right? So if you'll talk about the you can say this one, the first hint, right? So it is saying that find the connected component of the graph, right? And to find the connected component you have to use union find. If you'll talk about, if you know about, right, you can use you can say BFS, DFS, right? So the question is exactly saying what you have to do. Another example is saying that hint is saying that for a node u, right, number of nodes that are unreachable from u is the number of nodes that are not same as the connected component, right? And hint is also saying that the third, number of unreachable node from u will be the same for the number of node that are unreachable from the node v, right? And if nodes v and u belong to the same component, right? So first of all you have to find the component, and then you have to check with the each node, right? So we'll talk about that, don't worry. Okay, so first of all we will try to go with you can say depth first search, right? So in this video I'll try to complete all these three: depth first search, breadth first search, and union find. Okay, so we are talking about from more than 2 days depth first search, right? Then we will if you not have idea, I'll suggest that after watching this video you also go to watch the last 2 days video, right? So we are daily providing, you can say, daily Leetcode questions, and that will help you in the long journey in your preparation. So if you have any doubts, please ping in the comment box. I'll also provide the breadth first search and union find videos. So let's continue. So first of all what we have given here is as you can see, right, we have given a undirected graph, right, with n number of nodes, right? That it is saying that we have from where to where, 0 to n minus 1, right? And our task is to return what, you can say, the total number of pairs of different nodes that are unreachable from each other, right? So if we'll talk about the depth first search, then what we should do, right? So we will use you can say, let's suppose depth first search. So if you'll talk about you can say, let's suppose we have initially we have given what, 0 node given, 2 node we have given, let's suppose it is connected with 4, and 5 that we have already given this example, right? This one, right? And another node was what? 3 we have, and here is 1 and 6 is connected, right? So these nodes are connected. So it is saying that, right, there are, you can say, 3 component with the 7 nodes in this graph. So if we'll talk about, if we'll count all these nodes, we have 0 to 6, means 7 nodes we have, right? And so this is let me change the color. Yeah, so if we'll talk about that, this is our first component, right? This is our second component, and this is our third component, right? And this example, I'm talking about the example 2 that we have here, right? Let me reach here, right? So this is our, you can say, this is our first component, this is our second component, and this is our third component. Okay, so the first component, how many nodes we have here? 4 nodes we have, right? And in this, what we have? 2 nodes we have, and here 1 nodes we have, correct? So total 3 components we have, and what we have? Total 3 components we have, and each component is not connected with each other, right? So if you'll talk about the depth first search, right? If you talk about the depth first search, right? So our intuition is a connected component of a undirected graph, right? That we also know about, like you can say, we are talking about a subgraph, right? In which each pair of node is connected with what? Each other by a path. And it means that nodes in a connected component can reach all other nodes in the same component. However, if 2 nodes belongs to, you can say, different component, right, it is impossible to reach one node from other node. That we can see here, right? Now let's suppose we have given these 3 nodes, right? 3 components, right? And what we can see here is that there is no path between any 2 nodes, right, from different components, right? So the first consisting of so you can say, for the first component, that consists of what? 4 nodes, right? So for the first component that we are talking about, this one, right, how many nodes we have? 4 nodes we have. And you can say, except for the nodes in their component, right, these 4 nodes cannot reach any other nodes, like either they cannot go to here or here, right? So let me clean this one. Okay, so these 4 nodes cannot directly connect with this one, right, that we are talking about. Okay, so these 4 nodes cannot reach any other nodes, right? So what you can understand here, so our you can say like any of the 4 node from the first component, or any other node from the remaining component, either from this one or this one, right? From any other nodes from the remaining component, it results in a pair of nodes that are unreachable from each other. So the total number of pair of the nodes with one node in the first component and the other node in any of the remaining components, right, would be equal to the number of nodes in the first component, that is multiplied by the total number of the nodes except the first node that we have, right? So what I can say, let's suppose we have total we have 4 nodes we have here in this component, okay, and this component, and total what we have, total component total nodes we have 7, and 7 means we'll do 4, right? So what will happen? Total you can say 12 pairs we have, right? Now similarly, if we'll talk about this one, how many nodes we have, right? So first we'll talk about this one only. So see, what we are trying to achieve here is, we are trying to find total, you can say, pair, right? And to find the total number of pairs, with one node in the first component, right, the other node in any of the remaining component would be equal to the number of nodes in the first component multiplied by the total number of the nodes except the first component nodes, right, and that is 4 into 7 minus 4 equal to 12 pairs. It means there are 12 pair nodes that are unreachable from each other, right, where one of the two nodes are in the first component. Understood? Now let's move to the, you can say, second component, right, that we talk about. Okay, so which is only one node, 3, correct? So the number of unreachable pair of the nodes with you can say one node in the first component in the second component would be the total number of node in the second component multiplied by the total number of nodes except the current component, and the first component that we already covered formed using nodes in the first component, right, it is now we will do what, 1 into 7 minus 4 minus 1, correct, that we have already done this one. After doing the minus, I'll do the minus again, right? So it is 1 into what, 7 minus 3 is 7 minus 4 is 3, minus 1 is 2, so I'll do 2, so total 2 pairs are there, right? And so we can say that we have now covered all the pairs formed with you can say one node in the first component, right, as well as the pair formed with one node in the second component, right, because we only have third component left, right, here this one, right, and so that no more pair of the unreachable nodes can be formed, right. So total number of pairs required is what, if you'll do the plus, is 12 plus 2 is what, 14, correct? We have got here 12 and here we got 2, correct? So therefore to find the total number of pairs that are unreachable from each other, we must iterate over the graph and we'll try to determine the size of the component, right? So when we multiply the number of nodes in the current component by the total number of nodes, right, in the graph, we will ignoring nodes in the current component and previously visiting all the components, right? So we have already covered pairs of the node that we formed with one of the node in the previous component, and to get the required answer, right, we add these numbers of the pair nodes while iterating over all the component by one, right? So as we calculate in this example, right, what we will do, we will do a depth first search traversal, and that we will use to determine the number of nodes in the each component, right? And so that what we will do, we'll do DFS, right, and we use a recursive function, right, to iterate or explore the nodes, right, you can say, as far as the possible to each branch, right, and that we already understood, right, for each branch we will do the iteration, and so that we have to take recursive calls, right. So upon reaching the end of the branch, right, we backtrack to the previous node and we'll continue exploring the next branches. Okay, it means in DFS we use a recursive function to explore nodes as far as possible along the each branch, right, and based on reaching the end of the branches, we backtrack the previous node and will continue exploring the next branches. So once we encounter an unvisiting node, we take one of its neighbor nodes, right, if exist, as the next node on this branch, and we recursively call the function to take the next node as the starting node and will solve the problem, right. And you already aware with the depth search, right. So what we will do, we'll go to the browser and we'll try to implement here, right, count pair function, right. So we should use you can say adjacent map we will take, right. So first we'll take map, and this map will take first node in teaser, and it will take what, list of you can say neighbor node, right. So I'll take a list, and this will take what, I'll take integer, and that's all, right. And this is our adjacent, and we can say this is pair, adjacent pairs, adjacent node, that's fine, we'll take adjacent only. Adjacent nodes, you can say adjacent map, right? Leave it adjacent, we'll take adjacent new, and this is our has map. Okay, next what we will take, what we will do, we have edges we have given, right? So these edges we will iterate over the edges, and this is nothing but our single array, and this is edge, and we'll take from what edges, we are iterating on the edges. Okay, now what we will see, once we will iterate this one on the edges, we will have each edges. So edges at 0, we will have what, node A, let's suppose node A, and edge at, you can say 1, we have what, node B. Got it? Node A and node B we have. So node A and B is connected, right, to make the pairs, right? So what we will do, we will take the, we have adjacent, right? This adjacent we have, and here we'll take a, we know that we will use compute, and if absent we'll use the is, I'll take adge at 0 means node A, and I'll take nodes, you can say neighbor nodes, right? And neighbor nodes is connected to a list, right? A list of neighbor node will be there, right? Or you can say pair, or you can say pairs of node, right? Pairs of node, and this is nothing but our array, and this list, array list, will contain what, integer type of list, right? Integer type of node, you can say, and to create a new array, right? And we'll, after initializing the array, we have to add here, right? So on the add, we'll call its pair node, that is nothing but at 1, correct? I think what I did here, so here I have taken what, edge of 0, and this is a pair, and this pair will take what, we are initializing this one, and that's all. Yeah, it should work. I think it will go here. It should work, right? On the add, no, this is all. Next, what we'll take, this one will take here, and we'll say this is 0, and this is nothing but our 1. It will remain same. This is for node B. Now this is done. Now what we will do, we'll take number of pairs, right? So coming to here, what we'll take, we'll take number of pairs, right? So I'll take long, right, and number of pairs, right, we'll take, and this is nothing but our 0, and there is we'll have long and size and of component, correct, and this is nothing but our 0, if you'll see. Now what we will do, we have what are the remaining nodes we have, right, that will take also. So we'll take long remaining node, and you can say is nothing but our n. Okay, so this is done, and one more thing, we'll take a visited node, right? So this is nothing but we will take boolean array visited node, and that is nothing but our new boolean. That's all we have for today. Okay, and now we will visit our the node, right, all the nodes. So we'll take for loop, and we'll start with what, I equal to 0, and I should be less than n, and I plus plus will do. Okay, so here what we'll do, first of all we'll check if visited node we have, right? So if this visited node not equal to visited node, right? So what we will do, on the visited node we'll check I. Okay, and here we'll find the size of component, right? And this is nothing but our DFS. Will use utility, DFS utility method will call, and this DFS utility method will take first its node, root node will, we can say, then we'll take adjacent map, right? And another will take our visited node, right? So this DFS utility method will find the size of the component that we are seeing, that we are calling what, 4 into what, 7 minus 4, and we are doing what, 12, right? Means 4 into 3 is 12 nodes, 12 pairs, right? 12 pairs we are finding, right? So this is you can say size of component it will get from what, this DFS, right? And we will try to find this one. As you have seen already the video, you will understand this one. Okay, and to do that we'll do that you can say how to implement that we will see, right? So first from here we will get the size, right? And we will implement here to get this 4, right? And to get this 4 we have to visit this, you can say DFS first, right? Good, to get the this 4, right? So we have to find like this size of the component. Once the size of component is ready, then what we will do, we can implement this one, right? So you can say find here, find all nodes in the component, right? And we will do, once the all nodes find, then we will do the calculation, right? So now here we will find what, number of nodes, number of pairs, right? You can say, and this is nothing but if we have previously some value will be there, right? And from here, right, what we will do, we'll do the calculation, right? So we have the size of component, right? And we have the remaining we also have, right? So I'll take the remaining here node, and from the remaining node we'll do the minus what, the size, correct? Like this, as you can see, this is done, right? So after doing this one, we have our remaining nodes, right? So on the remaining nodes we'll do minus now, because we have already calculated the number of pairs for these component, right? So now we have size component, for the component we'll do that minus, we will have now remaining nodes, correct? This is called logic. Okay, the remaining nodes will come again and will find our number of pairs, each time will get updated, right? And all is doing only because of this recursive call of the DFS, because each time it is calling, getting called, and it is returning number of size of the component, right? Once everything is done, right, what we will do, we will return our completing here, we will return, you can say, our number of pairs. Okay, and everything is done only because of this DFS method, right? So what we will do, we'll try to create here. So this is not returning anything, right? So what we will do, this is sorry, it is returning a size component, right? And this is our long, right? So you can take long here. So I'll take let's take integer, don't worry, and DFS this one. So I'll create this body. So till now what we have done here, we have taken adjacent, right? And after that from the adjacent we have prepared our, we have initialized our adjacent using the given edges, because each edges contains undirected graph, undirected you can say pair, and from where we will get our node A and node B, and so that we will initialize each node. Once this is done, we will take some variables to calculate the you can say number of pairs, right? And once the number of pairs is ready, we will return the number of pairs here. and we will find the nodes number of size of the component only through the DFS. So that's now we are going to do this DFS. I think you understood, right? So let's go and we'll create this function, right? Okay, so first of all, we'll this node is nothing but I is nothing but what? This is our you can say root node. So I'll take as a node, right? And another what we have adjacent, right? So we have already created the adjacent map, so I'll take the definition from there and I will put on here. Now we have visited node, so I'll take from here. Okay, now what we will do, we will make connections, right? And we'll loop onto the neighbor nodes. From the node we will get the neighbors node. Okay, so I'll take first of all, let's suppose account, right? Number of count of the node. Okay, so we'll take int count nodes, and that is nothing but our 0. Okay, or at least one node will be there, right, when we are passing the current node. Okay, and now what we'll do, we'll check the if the this node is visited node, right? So on the visited node we'll pass our current node and we'll mark this as a true, that now it is visited. If this node is not on the adjacent, right, then what we will do, we'll do contains key, right? So contains key of this node, if this node is on we can say adjacent, then we have to do. So in this case it is not doing anything, so what we will do, we will return our count node, we will return our count node just. If it is onto the adjacent, right, then we will continue doing our code. So here what we will do, we'll go to our from the adjacent, right, we'll do adjacent, and on the adjacent we'll get this node, right? And from this node we'll get a list of node, right? You can say it's neighbor node, you can say. So I'll take a int neighbor node, and this is nothing but our neighbor node. So I'll go here and we'll say if our visited node, if visited node contains our neighbor node, right, then fine. Otherwise, if this is not onto the visited node, means we have not visited this one, and so we'll count this one, right? So I'll take our count node and we'll do increment our count if it is not visited, and do little DFS utility. We'll do the DFS utility in which we will pass our neighbor node. Let me write from here only, because just we are doing nothing, we are calculating our this one. So just in the place of I, will use our NEI as a node, neighbor node, right? And everything will remain same because we are just counting the this one. Okay, once this is done, we will return our you can say count. So we'll return count node. So we are done. So what I am doing here, actually in the DFS we are taking initial node, because if for any node there is count will be at least 1, so we'll slice with 1. We'll mark this node as a true. If this is not visited, this is not on the adjacent, right, then we will return our count node. If it is on the adjacent, we will check its neighbor, and from the neighbor we'll check neighbor is not visited, then our update our count and we'll return this count, right? That's all for today. So let me compile this one. Okay, it's working. Let me submit this one. Very good. So you know about this one, right? Study we also talk about that time complexity TC and space complexity both will remain what, O of n plus E. Why? Because see, why space complexity and time complexity remain same, because see, we have edges right here, so we are moving all the edges from first edges to last edges, right? All the given edges connections we have, right? And we are traversing all the edges, so we are getting O of E time, and space also, we are also using adjacent, right? That's why time and space will take O of E, right? Now as you see here, we are going for all the nodes, right? So here it will take O of N, right, to store and to traverse both, right? And that's why we are getting time complexity, space complexity, N is node and E is as. Okay, let's submit. Thank you guys. If you like this video, please continue watching the other part of this video, right? In the another video. Thank you so much guys. So I'll post another video, you can watch there.